Welcome to session 9. Our first talk of the session is from Christoph Aurnhammer with a talk entitled The P600 as a Graded Index of Integration Difficulty.
Okay. Yeah, I'm Christoph Aurnhammer. Today I'm presenting the P600 as a graded index of integration difficulty, which reports on my last experiment, which I conducted together with Francesca Delogu, Brouwer and Crocker at Saarland University, which is where I'm working on my PhD. So we are working with ERP components, and we are working on the functional interpretation of ERP components. And specifically, we are working within retrieval integration theory. And on retrieval integration theory, we take that the processing of a word makes use of the word form that you perceive. You make use of utterance context, and the goal of processing is to create an utterance meaning representation. And this process function can actually be subdivided into two more functions, first of which is the retrieve function. And here you take the word form, you make use of utterance context, and you want to retrieve a word meaning representation. And we take that retrieval is indexed by the N400, and of course we share that view with several others as well. And second, the integrate function takes the retrieved word meaning, again makes use of utterance context, and maps this to an updated utterance meaning representation. And here I should say that it's really the utterance meaning representation which feeds back into both of these functions as utterance context. So this is how we capture context effects. And we take that integration is indexed by the P600 component. Now, one prediction that follows from that is that P600 is actually listed by every word, because every word needs to be integrated. And the amplitude of the P600 should provide a graded index of integration difficulty, because not every word is integrated equally easily. Now, some preliminary evidence, actually data that I had the chance to present at last year's MLab, where we looked at only the data of a baseline condition of my experiment. And the sentence went something like, yesterday the lumberjack sharpened something, the X, and the target word X generally was expected, but there was actually variability in close probability here. And what we found was, using an RERP analysis, that both the N400 and the P600 appeared to show graded sensitivity to the expectancy of the word. And again, within retrieval integration theory, we think that this is due to different underlying mechanisms, because expectancy affects both retrieval and integration. Now, this was a postdoc analysis, and we wanted to study this in a dedicated experiment. And here we actually took strong inspiration, as you will see, from a very nice study by Newland and van Berkom in 2005, where I'm showing a transliteration from German here. And in this design, you first get a context paragraph. And in the context paragraph, a story is being told and a discourse is being established. So the story is about a tourist who wanted to take a huge suitcase onto the airplane, and so on and so forth. And then you get 1 out of 3 continuations to that. The first is just a plausible baseline continuation. The lady dismissed the tourist, she sent him on his way. And the second one, we have a less plausible continuation. The sentence goes, the lady weighed the tourist. Now, that's not a very plausible thing to do, but it's possible to weigh a tourist. And yeah, I already said it. What you actually expect here might be the word suitcase, right? Because she's at the counter and she may be weighing the suitcase. So not only is tourist a little less plausible, but also you have actually built up an expectation for a different word, which is very salient in the discourse. And thirdly, it's just a very implausible continuation. The lady signed the tourist. Now, several things that we implement in this design. First of all, we use a context manipulation here. And this, of course, has several nice effects. We don't have to worry about frequency differences and all that stuff. Second, we employ a lexical repetition here, right? Because the word tourist we've actually already seen 4 times in the context paragraph. And there's not really a difference with regard to that across the conditions. So the lexical repetition is exactly the same in all 3 conditions. And based on the retrieval view on the N400, we actually expect no N400 differences as a result of this, because there should be equal retrieval facilitation across the three conditions. Now, this has one very important consequence, namely that we often have to deal with component overlap, namely that, which is that different ERP components actually sum on the scalp, and you always record the summed activity of potentially several components. And in the case of the N4 and the P6, they're actually opposite in polarity, which means that if you sum them, they cancel out partly. And hopefully, we can address this problem using this design, which ideally should result in no N400 differences across conditions. Now, of course, the main manipulation that we employed was the step plausibility pattern, right? A is more plausible than B is more plausible than C. And based on the integration on the P600, what we expect that the amplitudes of the P600 should exactly pattern with that. Now, lastly, I already said there's an expectancy for distractor word in condition B. And again, because we hope that we can actually avoid N400 differences, this allows us to get a very clear view on any additional modulations that this confirmation that this effectively is may elicit. Specifically, there's of course literature about frontal positivities in the later time window, and we can get a clear view on these. So we just ran some pre-tests because we wanted to validate whether the manipulations that we implemented in the design actually worked. So we collected plausibility ratings for the target words. And as you see by the vertical bars, we exactly have, those are the means of the conditions. We exactly have the step pattern, but also importantly, we actually have per item ratings on the scale, right? And we can later use that to model the data. Second, we also wanted to validate the expectancy for the distractor word suitcase in condition B. And indeed, in condition B, there's high expectancy for suitcase, but in the other conditions, there isn't. Now, the first study was a self-paced reading study. We first wanted to just see whether the manipulation of plausibility induces behavioral pattern. And in this experiment, we also presented comprehension questions on 50% of the trials, and actually the performance on those was very, very high. So now I'm showing the reading times, time logged to the word tourist on the second region. And there's definitely something going on across conditions here. But very importantly, what we also see is that actually before the critical word was presented, there's already a difference in conditions here. And this is most likely due to the context manipulation, right? The verb differed that you got. And we need to address that because otherwise we may wrongfully assign a plausibility effect to what's actually has been happening already before the critical word, right? And we do this by fitting separate linear models, regression models for each of those regions. And then we actually take the observed reading times on the pre-critical region as a predictor for the reading times on all the other regions. And what this does is that once we enter our actual predictors, the target word plausibility ratings and the distractor close probabilities, we sort of account for any pre-critical reading time offsets that may already be in there, right? And jumping directly to the Z values and p-values indicated by those little dots, of course, the pre-critical reading time predictor is very strong. That's not surprising. But indeed, plausibility actually explains variability in the reading times over and above both the other predictors here as well. So this was just a step of validating that the stimuli we created actually induce graded integration difficulty, right? And more of an aside, we didn't find any significant processing cost of the disconfirmation here. Now, of course, to the main bit, the event-related potentials. Again, the same task. Again, very high accuracy. Also, I should say there were no really reliable differences across conditions here. And what we then found in the ERPs is that in the N400 time window, there wasn't really any pattern with plausibility here, but we did find an earlier negativity for condition B here. And it's in its time course, for example, its peak, it seems a little early to be an N400. And again, recall that in exactly that condition B, there was a high expectancy for the word suitcase, which was then not presented. So it could, for instance, relate to a mismatch between this very strong prediction to what you then actually observe. Now, second, in the P600 time window, right, those waveforms exactly match the three conditions that we created. So the most plausible condition is least positive, and then with increasing implausibility, yeah, the waveforms become more positive. Now, to analyze those data, we conducted an REAP analysis, and here we actually use very similar models like before, and we fit one of those models for each subject, for each electrode, and for each time sample, right? So the model specification is always the same, but you just repeat the model fitting process as you move through the signal through time, and you can repeat the same for all the electrodes, and you can do it individually for the subject. Now, this has the effect that you can then actually graph what your coefficients look like across time here. And usually there would also be error ribbons indicating the variability across subjects. I just removed these because it's easier to see the lines here. And first of all, focusing on the distractor close probability, which captures the disconfirmation element. Right, it captures this little earlier negativity bump that we got, and it actually does so significantly too. And one very powerful method that we can now use is that we can basically multiply this vector of distractor close probabilities across time with the per item close probability values themselves. And then we can set the other predictor in our model, the plausibility, basically to its average value. And this basically shows us what the waveforms would look like if the conditions didn't actually vary in plausibility. So it isolates the contribution of distractor close probability. And what we then see is exactly, it captures the negativity. There may also be some inklings of a positivity later on, but I'm also showing the parietal electrode here, and you may actually expect frontal positivity, right? So I'll get back to this. So we just rinse, repeat that process for plausibility now. Again, so this guy turns significant in the P600 time window. You multiply your coefficient vector with your per item plausibility ratings. You turn off the other predictor in a way, and then you can show what the isolated plausibility estimates look like. And this is what we then obtain. Again, I think this really shows plausibility doesn't predict any sort of N400 modulation here, and it's really the P600 that varies as a function of it. Now, one last bit of data that I want to show. Now we're really focusing on the B condition. And in the B condition, we had both the reduced plausibility and the expectancy for a different word. And we can now see whether we can tease those apart a bit more. So first of all, this is just the topo map for that condition, very broadly distributed. And this is the topo map of the data estimated by our regression models, actually. So what we're doing with the REP method, we actually recreate our entire data set, and you can imagine that we replace every observed value with an estimated value. And you can just visualize those in any way, for instance, as a topo map. And I think overall, it seems we're capturing the major trends in the data here, but you can also quantify that simply by subtracting the estimates from the observed data, right? Which is how you compute the residual error anyway. And then you can plot the residual error, and yeah, ideally you get a very wide topo map because there's not a big difference. So again, the estimated data on the right, and regression is very additive, purely additive, right? So you can again use the same trick that we used before to show only the contribution of plausibility and only the contribution of distractor close probability. And what we find is that actually the predicted waveforms of plausibility, if you show them as a topo map, are very clearly parietally distributed, which I think is exactly the canonical P600 distribution. Whereas distractor close shows a smaller but clearly left frontally distributed topo map here. So I should say distractor close actually is not significant on those electrode, but I think given the literature, this is actually what you may expect, but I'll leave that to you. So in sum, we just replicated several things here. First of all, the reading times showed a plausibility effect and increased integration difficulty induced slow reading. Quite nicely, I think we also managed to replicate a lot of the original experiment here, where we did not find an N400 effect. And we think this is due to the equal retrieval facilitation due to the lexical repetition that we employed, because it really primes the word tourist, because you've seen it 4 times already. And second, there was a presence of a P600 effect in the original data, and also we replicated this, and we explain it in terms of the difference in integration difficulty, because one of the sentences was plausible, the other one wasn't. Now, some novel findings. The disconfirmation of the distractor elicited this earlier negativity. I think many experiments looking at disconfirmations often elicit both an N400 and a frontal positivity. I think exactly because we managed to remove the N400 from the equation here, we are maybe able to get a clearer view on this, because otherwise this earlier negativity may just overlap with the N400 and would be one big deflection. So that's at least one possible explanation. And a little more tentatively, I think we also found exactly the frontal positivity, and interestingly, it can co-occur with the parietal P600. For the N400 itself, we did not find that it was modulated by plausibility. Rather, the P600s that we obtained were graded for plausibility, and recall how we modeled these data using the continuous plausibility ratings. We here want to argue that the P600 actually provides a continuous index of integration difficulty. Thank you.
So, thank you for finishing very timely. We have lots of time for questions. Just a reminder, the student microphone is on the right, and we'll prioritize student questions. Okay, we have a question from Zoom.
Okay, hi. Thanks for your very interesting talk. I have a 2-part question. First, I was a bit puzzled by your very high comprehension accuracy results in both experiments. Whether you could say a little bit more about how those questions were formulated, like what were they asking for? And second, maybe I didn't miss it or didn't understand, how long was your word duration of the target word in the ERP experiment? You
mean the duration of the presentation?
Yeah.
Okay, so we used, I think, very common presentation rate with 350 milliseconds presentation, and there's a interstimulus interval, and then the next word appears. And you can also see it by this typical inflection when the word disappears. About your first question, we used comprehension questions. So they were just questions like, did the lady dismiss the tourist? And that would be really about the manipulated region, but the question could also be about any part of the paragraph, actually. Also, the fillers items sometimes included implausible sentences in the context paragraph. And sometimes we asked about this too, because we really wanted the participants to very attentively read the context paragraph as well. And they also took a long time to complete the study, which I think is also because of the task, and they were trying to really be very accurate in their responses. They took time.
Okay, thanks.
Yeah.
Okay, we have another online question from Stefan Frank.
Hi, Christoph.
Hi, Stefan.
Really nice experiment and nice results too. I have a question about the use of these close and plausibility ratings. Presumably, these are different participants, right? These are not the same as in the EEG study.
Yeah, these were collected offline. Yeah.
But if the variance among participants must be considerable in their ratings, so assuming that the variance is pretty large, then how useful is it to use the average of these ratings for a new set of participants?
I think it's the typical way we do it, right? So we collect about 10 or 12 ratings for each item and then average those. So, I mean, we could, of course, just also report on the variability across participants in the rating task to get more of a feel for that. But yeah, was that your question?
Do you know anything about the variance? I guess from the top of your head might be hard to answer, but are they?
I don't know from the top of my head, but I think we looked at it when we created the stimuli because we, of course, did several rounds where we optimized a lot of things. And if there is a particular item that, I don't know, is either rated as plausible or as implausible, then that's exactly not what we want, of course.
Yeah. Okay, thanks.
Okay, and another question from Milena Rabowski.
Hey.
Hi.
Yeah, thanks for the very interesting talk. I found it interesting that the paradigm you adopted from Newland and van Berkom, that the results were interpreted kind of by the original authors as reflecting a semantic illusion in the sense of the kind of a misinterpretation, an initial misinterpretation based on semantic heuristics, kind of based on the semantic relatedness of the target word and its overall kind of relevance for the scenario. And the P600 was interpreted by them. They didn't take a very strong stance, but as possibly something as a revision process or a reinterpretation of that illusion, which also seems to make sense in the sense that kind of it seems that these sentences in these contexts might give the impression to participants that they could be reinterpreted some way that could make sense. So I guess I'm wondering whether you think that your results, which now I think very nicely replicate these original results and also extend them, whether from your perspective they are incompatible with this original interpretation by the original authors?
So I think that you could apply the original interpretation to the condition B that we had, where you also expect the word suitcase, but then you get tourist. And if you take that participants really use the globally available information, they maybe use the word suitcase and insert it here, and that would be their initial interpretation. But I think that exactly does not work in our condition C. Condition C is in many ways just like a sentence like, I don't know, he spread his warm bread with socks. And yeah, you usually get an N4, and we didn't get it. And the only thing that we did additionally was to apply this very strong priming.
Even so, in some sense, I feel there's some difference because the tourist, different than the socks, is actually relevant to the scenario, right? And you don't sign a tourist in that situation, but you do sign something, maybe the ticket of the tourist or something. So yeah, but I guess that's yeah, thank you.
Yeah.
So we have time for more questions. I might actually ask one. Maybe it's a little bit related to what Melinda was saying, but in the you've got this attenuation effect with all the lexical priming for the N400. And in your condition B, you've got shared lexical content with Wade appears in this preamble, right? But in condition C, there's no shared lexical content with that preamble. So I was wondering if the same attenuation effect maybe also affects the P600. So you're seeing like an attenuated error signal in B versus C.
Why? So are you saying the error attenuation is larger in C than B?
In B than C.
But the error itself is larger because you expected something specifically, right?
Yes, but maybe there's just, I'm just like thinking.
Okay.
Yeah, maybe there's just some lexical kind of attenuation of that just because you've got pre-activated the word Wade in condition B.
Yeah, I think we could probably, I don't see a way in which we could quantitatively look at this, so I think this would come down to different interpretations in the end. Yeah.
Okay, then let's thank Christoph again.
Thanks.